And then also if you're in like the kernel poppers Slack channel or whatever, you probably found many a solution anyway, but just in case. So if you're running Firefox on Windows, you will notice the console plugin is no longer supported. That comes from way back in the day of a browser called Netscape Navigator. Made the Netscape plugin API, NP API. So there was NP API for doing browser plugins, and there was ActiveX controls for doing plugins on Internet Explorer. So even back in the day, the world would do it one way and Microsoft did it another. And that's just what we've been used to ever since. So the sketchy thing about the ActiveX controls, because they're really insecure, and to an extent the NP API, is what is happening is you're going to a website, and in order for this API to function, like when you go to any website that requires Flash, you will notice when your browser sees the little signal that says, I need Flash, if you go in, there is an actual executable launched. So just by the act of visiting a web page, there's executables being launched on your computer. Now, if Flash was remotely secured, this wouldn't be a big deal. But between Flash and Java, which are both NP API enabled plugins for your browser, they're all terrible in their security. So we'd have outside websites interacting with an API on an executable on the computer. Your browser could be the most secure thing in the world, but as soon as you launch this plugin, it's a bad deal. So Chrome long ago ripped it out. They completely got rid of the copy and pasted the code for doing NP API inside of Chrome and just deleted it kind of deal. So it's gone, which is why Chrome has a not normal version of Flash. It has like a Google-blessed version of Flash embedded inside of it. So Firefox has been rolling NP API forever. And just, well, was it last week ago? Officially in their build, pushed out the new version where they disable NP API, is what they claim anyway. What they're really doing is just masking it and only allowing Flash to run.
They killed
plugins. Yeah, it does kill every plugin that's not going through now Firefox's blessed plugin system. So what's that?
Is that website?
I don't know.
Because I think that was one of the things mentioned in the article of why they're using it.
Oh, because they have their own kind of thing.
It's theirs.
So regardless, yeah. The vCloud plugin, the VMRC plugin, which we all know and love and prefer typically, unless you find other means, which is cool too. You would come here and these other options are just gone, and there's only Adobe Flash because plugin support is just gone. So, a couple choices for what you can do. You can go into the About config and find the right config line. And there is actually it's not hidden, it's just gone. You have to add it back in manually. It's basically like the registry of your browser of Firefox. And you can tell Firefox, load NP, or enable other plugins other than Flash. Literally, it's don't enable just Flash kind of thing or something, some text like that. The other option, and this is what I opt for, primarily because Firefox is clearly in these builds of Firefox trying to get rid of this API. So they're probably eventually going to get rid of it once they solve the Flash problem. So what you can do is download Firefox ESR, which is Extended Support Release. And the reason why I have this talk in general is I casually suggested it to someone that was kind of a tinfoil hat kind of individual who felt that downloading the extended support release of Firefox 52 is you're locked into Firefox 52 and you're never getting updates, and that's not necessarily true. When you download, this isn't something new that Firefox does. You can go look for Ubuntu. It's just a random example. All sorts of, if anyone makes software, they do Microsoft does this all the time.
Not worth it.
That's not Ubuntu. Ubuntu.com. That
Was
looks.
Nelson Mandela and Obama?
That was definitely Nelson Mandela and Obama. Yeah, don't know what was going on there. But anyway, like if you come look for Ubuntu and go to download Ubuntu server, you notice the top link they give you is Ubuntu server 16.04.2 LTS. That is an older build, or a less features added, minor revisions, than the one we have down here. So why is Ubuntu putting out two different versions? Yeah, so it's the long-term support. So basically what Ubuntu is saying, you can download and install Ubuntu 16.10, right? Any problem with that? No. If you're a business and you install Ubuntu 16.10, what's going to happen about a year from now? Ubuntu is going to say, great, you've got 16.10, that's nice, we've moved on. When you download these just regular support cycle versions, and I don't know if it's a year or what it is, I don't know the number off the top of my head, they're saying, hey, we're working on new features for this OS. If you download it, great, we'll support you for a small period of time. Eventually, we're going to move on. So if you want long-term support, which generally on servers and in businessy kind of places you do, because you're not going to feel like reinstalling the OS on your servers every 9 months, because that's unpleasant enough, let alone if you got to do it on a regular basis. So when you see the LTS version, we see that they are going to support this until April 2021. The idea behind it is Ubuntu is not going to add any radical new feature to the LTS version. Like, you download this, you get an operating system that works and it's got its feature set. When Ubuntu comes out with, I don't know, like radical new kernel build with cloud embedded into the kernel or something stupid like that, this version will not get it. This LTS version is just going to get security patches. Like, we found a flaw in the kernel and we're fixing it. You'll get that. You won't get radical new crazy feature. Same thing going on here. When you pull down the extended support release of Firefox, you're saying, I want the version that you're in it for the long haul for. So right now Firefox says 45 and 52. Either one of them will work for the iLab. I'd grab 52 just because it's newer. But 52 will support everything you need. Grab the not 64-bit edition. Most NPAPI plugins will not work with 64-bit, with the exception, I think, of Flash. Otherwise, pretty much everything needs 32-bit anyway, including the iLab stuff. And then obviously, I mean, if you want to go on an adventure, pick a fun language, but I would scroll down and grab English. So, yeah. That's our talk on browser plugin. Since this was long ago, you notice that you don't need the plugin inside of Chrome anymore. That is because VMware pushed out an update for the software we use that says, okay, we're going to send Chrome over to a kind of crappy HTML5 renderer. VMware has not updated the software for Firefox yet, so that's kind of why we're like having this talk in general. Otherwise, I would have just applied the patch before the Firefox update even came out, and none of you would be any the wiser that anything probably happened. But that didn't happen. So, meanwhile, if we look inside of the lab, regardless of whatever browser you're using, you should all have a Splunk virtual machine. I did not pre-start them for everybody, so if you want to fire it up, we're going to talk about Splunk a little bit. So what's the purpose of Splunk?
It kind of like channels all the logs.
What's that?
It channels log files.
Yeah. So it eats up log files. It's kind of like the Google of your log files. Like, Google just crawls the internet and gives us this big index we can search. Splunk eats up all of our log files and gives us this big index of logs we can search. So I'm not sitting here telling you that the most exciting moment of your life is going to be reviewing a log file. But you'll spend a good chunk of your life doing that, whether you're in security or not. You're going to look at log files someday. Or, I guess if you don't, life's going to be hard. If you look at log files, life gets a lot easier. So what Splunk does is makes that whole process easier. So we talked about the centralization of stuff before. So Splunk is a central repo for everything. But it makes it easy for us to use. It's one thing if we have Notepad open and we're trying to edit or read through a log file. So it opened like a greater than 20 megabyte text file with Notepad. Yeah, what happens?
It just like doesn't.
It usually gets her done. It's gonna take it like 5 minutes to open the file though. So, and there's better, like you could use TextPad or Notepad++ or whatever. There's better text editors out there if you're gonna open up and read log files. Don't get me wrong. But in the end, you're probably going to have a lot of log files. And maybe you're going to want to look at like patterns and interesting sort of information inside of log files. So that's what Splunk does for us. There's a lot of pieces to Splunk. So this is just kind of like, I have a couple diagrams that I stole just for generic talking points. I'm not going to do PowerPoints of text or Splunk training things. But there's two main pieces. There's the search head. And the search head is this web interface that we log into that we actually do our querying and execution, stuff like that from. So this is the search heads are basically like the user part of it, the user being like the people using Splunk to look at data. The other one is the indexers. So the indexers are the processes or servers that are eating data. You're feeding data into them and they're doing stuff with the data and storing. In our instance, we have everything running on one box. There's one server that's doing search head and indexing. If you're not throwing an enormous amount of data at Splunk, that's fine. But it kind of goes along the same lines as a lot of enterprise-y applications. Like if you go to work someday and use a email software called Microsoft Exchange, if you have 15,000 employees, you probably don't have an Exchange server. You probably have a rack of Exchange server, and they're divided out. The different components are on different physical servers. Similar thing going on here. If you have a big infrastructure, the stuff is going to actually be split apart. So search head, we do our searching, all that good stuff on there. And it's where we do our fun little web GUI. It's pretty and awesome. The other one is the indexers. So the indexers have two jobs. They parse incoming data, and there's tons and tons of ways that data can come in. And this isn't even like specific to Splunk. Like all of these engines work in a pretty similar way. So there's data that comes in, gets piped in, whether it's from a firewall, a router, a switch, or a heart monitoring machine or whatever. So it receives all this data, and the first thing it attempts to do is extract out real information. So real information being like, I have this blob of data. Here's a source IP address, here's a destination IP address, here's source and destination port, and I blocked it. That's the real data we want out of there. Otherwise, it's just text that's coming in. So this is something that we load in regular expressions into Splunk to do. You can write your own, that's cool, or you can go download them pre-made from Splunk or your vendor or whoever. So in our case, I fed our firewall, or our Splunk box, Juniper firewall logs. I actually just took the iLabs Juniper firewall and pointed it at this particular VM for like 40 minutes and called it good. So fed it data, it parsed it out and it indexed it. Now it doesn't necessarily have to extract out fields though. So when we look at the cool stuff that Splunk does, it actually is operating a map reduce function. So has anyone heard of that before? It's like when we use fun buzzwords like cloud, the fun buzzword here is big data. So there's a problem that actually exists with like the world right now. We're kind of in this information age where we can collect data off of everything. Like anything and everything collects data. That's cool, but the problem is we just have piles of data and can't do anything with it. So one of the problems with the data is that it is stored oftentimes in structured formats, like SQL tables, where the data has to fit into this column. If it doesn't fit into this column, we can't store the data there. So what MapReduce in the end is able to do is take all of these piles of data and look for strange patterns inside of them. So when we talk about that, that's something that Google is actually doing against your searches. So Google can predict disease outbreaks in large communities because they're just watching people's searches. They have these piles of data, of search data sitting there, and all of a sudden they start to notice a pattern of symptoms that everyone is searching for. And all of a sudden they can put it all together, and Google can actually predict specific strains of flu that are going on in an area. That's also a similar way that like the IBM Watson, only that's a very extreme machine learning kind of thing. But that works. It's able to take just piles and piles of data and actually derive conclusions from it. So we're not going to go quite that far with something that cool, like predict why someone's nose is leaking pus or something like that. But that is something that Splunk is able to do. We're not going to worry about, there's some, when we get into the interface, I'll show you a couple of the like summarizing tabs and stuff like that. For network data, at least the network data we have, it's not going to be totally useful, that part. The other parts still will be. So, yeah, we're configuring data to come in. If you're Google, you don't do this. You're just doing this whole thing in an abstract way. Then, so once we get all this data brought in, we index it, which is like the Rolodex style thing. So we put it in order. For the volume of data that even Splunk that we have running in this crappy VM, there's like 50,000 events, and it can sort through all of them like as you're typing. So its indexing engine is very good. It can access its own data very quickly.
And so I know that you're using Splunk at DSU, correct?
Mm-hmm.
So what made you decide to go with that versus other options that are out there? What's apart,
Well, there's a couple. There's like the hypothetical reason, and then there's like so here's why we're doing this reason. The hypothetical reason is that compared to all the other products, I'm comfortable with Splunk. It runs well. It's easy to set up and manage, all that good stuff. And then the like, here's why we're doing this reason is that Splunk gives us education licenses for stupid cheap. Not that other companies don't. It's just that Splunk is big enough and has a big enough like academic, researchy side to them that honestly, I think even all of you with a .edu email address can go get a big Splunk license for free. Like they're just going to see the .edu on your address and just be, yep, sounds good. Here you go. So,
if Splunk is using regular expressions to kind of like scan through the logs, is there like some kind of log standard that people usually like use? So like all firewalls would be based on the same kind of output, more or less.
Yes and no. And my comparison is so like, why wouldn't everyone just have standard stuff? And yes, I'd say yes, they should, because we blocked this IP, this port, stuff like that. But when we start looking at different firewalls, like if we look at the Palo Alto firewall versus the Juniper firewall, every individual rule had different data in there. So the Palo Alto firewall, we could do the same thing on the Juniper. It's just really hard to do. Enable deep packet inspection and actually analyze it. Port 80, yeah, that's great, but this is a web browser running, or web browsing going on. We can make that a part of our security policy in the Palo Alto, whereas the Juniper doesn't. So, yes, we have standard fields as in their firewalls, but then we start getting into the way Palo Alto does it. There's extra boxes that the Juniper is never going to fill out. It's just going to skip it, kind of thing.
So it's not related to like developers just making their own log.
Well, it is. Yeah. Yeah, developers are just, in all these instances, kind of like what we talked about last time too, of when we're pulling in this data, it doesn't have to just be from a firewall either. It could be from all sorts of things, all the way down to, we're not actually using Splunk. There's a current research project going on right now where DSU has actual electronic health record data that's been anonymized from Sanford Health, and we're basically applying the same concept to it to predict patterns inside of there. And the patterns, like I said, can go crazy from one way to the other. It could even be something as simple as like people that had a broken leg in 2003 now are coming down with crazy cancer. So there must be some sort of correlation that you can derive from it. So that would be an instance where there is no regular expression to match broken leg at this hospital at this time. That's just looking for patterns inside of random data, which is easy to do as long as you have enough processors sitting there eating it up, is what it really comes down to. In the case of for us, though, Splunk runs like super fast for us because everything is normalized. There are regular expressions that it goes to and parses stuff through, and I just have one firewall vendor in here. If I had a couple firewall vendors, it would have 2 different indexes it would have to read in order to get all the info on this IP. So then it takes a little bit longer because it has multiple places to look. This was the other one I just put in there for fun. Just something that you can run across sometimes where a lot of big applications where we can take it and install it all on one computer, or we can take pieces and rip it out and put it over there, and put some over there, and put 4 of them over there. So they'll actually put out a network diagram for how the software talks to itself. Because when we look at random one, the indexer needs to talk to the web interface, and if they're on the same box, that's great, but if they're separate, we need to actually allow firewalling between the two. So random stuff like that. Nothing super exciting there. So, yeah. There are, if you really want to go like down the full big data rabbit hole, I just read a slightly conspiracy theory style article on like Facebook actually testing that based on all of the data they have collected, they can manipulate someone's emotional state and continue their like browsing of Facebook based on like showing something that they know makes you mad followed by things that makes you happy, and they know you're happy because they have a like happy button that you click that says you're happy. So between that, there's like the concept that they could do a deep enough data analysis that they could actually fluctuate your political opinion one way or the other onto things, which is weird and crazy and far beyond the scope of what I'm doing here. But yeah, interesting article though of Facebook taking over the world, right? So in this particular box, we everything we do is just going to be through this web interface. Our username is admin, and our password is password 1bang, capital P on password, and we'll log in to a frankly not very exciting homepage here. So when I am learning a new piece of software, I'm usually the type of person that like I don't read the instructions. I just kind of go beat on the software for a day or two and just figure out how stuff works. And that's just how my mind clicks. And then when I'm really desperate, I'll maybe look at the instructions. So that's cool. Splunk is really hard to do that with because it's a very big application with many things inside of it. So I am going to give a few tours of if you want to tinker with this on your own, just a heads up of a couple things. So when you first get logged in, a very important step or stop for you to make along the way is going to be to go to settings and data inputs. So Splunk's sitting here basically saying, I'm ready for data, but you have to tell it to listen in some way. So when you go to data inputs, we have, like, it can, which I didn't even turn it on, but we can have it actually index the local Windows event logs. That's one option. Lots and lots of other options inside of here. There are, all of these are different types of forwarders that you can have. Oh, I thought I had a line of text, like something exotic about forwarders. So I don't. Splunk likes taking syslog data, stuff like that, but some systems don't do that. Some systems are remote, all that good stuff. So there's an actual Splunk agent you can install on computers that will parse data on the computer and send it to the Splunk server so that it can all get shipped away to the essential, sent over to the mothership. That can be anything as simple as what would actually be really structured data, like a Windows event log. Windows event logs are actually really good to query through because they separate things into fields and you can search them and stuff like that. Not that I'm sure anyone's been super jacked to search through Windows events, but it can be done. The other side is we could take that forwarder installed on a computer and just say, like in the case of VMware logs, VMware just ignores the Windows event log. It just dumps all of its stuff into log files stored on the file system. So we could say, hey, Splunk, watch this folder and send all of the data you see. And when it sees log files getting created, just ship them off. So when we look at these different types of inputs, there's all sorts of crazy ones. So local or remote event logs. So that would be Windows event logs. If we have WMI, the Windows Management Instrumentation or Interface, turned on, and we give it credentials, Splunk can actually reach out to your computer and suck up the logs off it. That's an option. Or we can install the Splunk agent and have it send it to the mothership. In the case of, that's actually what one I thought was cool, is you can have Splunk just execute scripts to generate data for you, or to go get data off of stuff, which is kind of neat. Or you can even tell it to, I think there's just a local, files and directories. Just watch this folder and index the data inside of it. So if you had, like, honestly, even an Excel sheet full of, probably not an Excel sheet, a text document just full of data, you could just dump it in a folder and Splunk's just going to suck it up. So neat, interesting, whatever. For us, syslog runs on UDP. So we can do structured ways of, like, you're going to monitor Windows event logs or Windows hosts and monitor its network interface, stuff like that. Or we can say, eat all the data you just see in this folder. Or in this case, with UDP, we can say, open a port, and when you get data coming in, just index the data coming in. So that's what I set up. It's just a UDP 514. It doesn't really have to be syslog. Like, you could just pump data over a network socket to this and it'll eat it. It's going to be weird, but you could. So this was set up for the firewall. If we go to new, though, we can just kind of look at and talk about some stuff. So when we go to new, making a new network socket listener, we have the choice of TCP or UDP. Why would we pick one or the other? Because there's pros and cons to both. So there's not a right or wrong. What's good about UDP?
Faster.
It's really fast. What's bad about UDP?
You have no way of knowing if your stuff got there.
UDP doesn't do guaranteed delivery. What's good about TCP? It guarantees delivery. What's bad about it? So if I want to send, let's say, 100 bytes of data, not much data, right? 100 bytes over a TCP connection or a TCP socket, I guarantee it's going to get there. My actual 100 bytes of data is going to take up how many packets?
Not a lot.
Hint, 100 bytes is pretty tiny. It's going to be a packet for the 100 bytes of data, yeah. How many packets is it going to actually take to get it there? I have to send a SYN. I have to wait for the SYN ACK. I have to send the ACK. So we have to do the whole three-way handshake. Then I send the data. So by my fourth packet's where I finally send the data. And then, of course, we're going to have a fin to finish out the session. So that's 5 packets to send one chunk of data. If we are a firewall and we are generating 1,800 firewall events every 10 seconds, how's that going to go? 5 packets minimum. Minimum barrier to entry. That's not going to go well, right? We're just going to exhaust the network because TCP, as much as we use it all the time, is actually a really terrible protocol for wanting to do stuff fast. And it actually kind of sucks. So we use UDP, usually in these situations. In the end, so if we talk about packet loss, UDP is not guaranteed delivery. In the end, is my day going to be ruined if I lost one log entry? Probably not. The other side of it is, if I have my Splunk server sitting right here, and then right next to it I have a firewall sending UDP data to it, they're probably connected to similar infrastructure in a similar data center, all that good stuff. Are we going to have a lot of latency or packet jitter or anything like that? We're going to have a lot of problems on the network that's going to cause dropped packets if they're connected to the same switch. I mean, where do we get packet loss and data jitter and latency and stuff like that? We plug it into the big network called the internet. if we want to ship syslog data across the internet, we're probably not going to be sending thousands of events a second. So we can probably just use TCP then and actually guarantee delivery. If you're sending, I would not send firewall syslog across the internet. But if it was like a temperature sensor somewhere, yeah, send it across the internet. I don't really care if someone knows that my living room is 60 degrees right now, or warehouse or whatever it is, right? So that's our TCP versus UDP. I'm just going to walk through pretending to make another thing, even though there's already one made. So we give it the socket number. We pick the protocol we want to use. We can give it an actual name of whatever we want to call it. That's fine. Then the other one we can actually do is specify only listen for data inputs from this IP or this host name or something like that. So that's the interesting fact of like the IA Lab syslog server or Splunk server. I think it's actually firewall, but I don't believe inside of Splunk I actually restricted the connection. So like anyone on campus could actually fire syslog events to the IA Lab Splunk server and it's going to index it. I don't really care. Well, unless you're sending like weird crap or something, but so that wasn't really a big worry of mine. Like the internet can't send data to it. Yeah. And what I actually, so this is set to be just any in the IA Lab. And then I have a firewall rule in front that says like the internet can't send syslog data. And that kind of came from the IT department being like, yeah, we'll send data to it. And they didn't know what they were going to send yet. So I was just like, campus subnet, send data. So that's specifying how the data is going to get there. The next part is specifying what kind of data is it that we're receiving. So there's tons and tons of different types that can be in here. So we can go down to like pull in MySQL data. So if your SQL server is doing stuff, there's different email. If you're using random send mail, the default firewall stuff I think is it's just Cisco that it has in there by default for an ASA and to take stuff from Snort. I'm sure it has Windows stuff. Oh, maybe not. Just Linux and raw syslog. Oh, and Windows. There's some Windows stuff. So anyway, this is basically specifying when this data comes in, what regular expressions do we apply to it? So that's where we can specify all those things. I, beforehand, loaded the Juniper module for here. So it has the regular expressions to understand when a Juniper device is talking to it. This is how to parse it out. So we can do that. The rest of this is really only specific, like if we had this split into multiple machines and indexing across the world here. So we won't worry about that. But anyway, that's the basics on how to get data into Splunk. So the other one that kind of becomes relevant for us, if we go to apps and then manage apps, it's going to be angry about not being able to connect to the internet, but what we can see here is like there's all sorts of like regular expression kind of things loaded in here. There's actually a really cool Palo Alto made a GUI with all sorts of data feeds inside of there that's neat. Juniper doesn't have a pretty GUI. They're just like figure it out yourself, which is what it is, I guess. So those are what's loaded. If you want to load other things, you can actually, like if you have a checkpoint firewall at home or something like that, if you go to splunkbase.splunk.com, you can search for all sorts of different things. So what firewall did I use? Checkpoint? Let's see if they have a checkpoint one. Splunk add-on for checkpoint. There we go. So if you had, I don't know what OPSEC LEA is, I'm guessing it's something from checkpoint. So we could download this particular file, load it into Splunk, and it would index the data for us.
Just a couple seconds ago, you saw the machine learning toolkit thing.
Oh, sure.
Is that a locally run thing, or is that something where like they get anonymous data on their server and then they analyze it there? Because if they do that, then wouldn't that mean they have access to all your log files in a sense?
Oh, this one, Machine Learning Toolkit. I bet this is like a learn to do machine learning on your Splunk box, is my guess. But, alright, forecast time series, yeah. So with all of these plugins, what you actually do is you download the plugin and install it on your machine. So if you're doing machine learning stuff, you would actually load it onto your own Splunk instance. That being said, you can buy Cloud Splunk if you're into that. So like if you go to Splunk.com and you don't want to buy your own server, you can, I'm pretty sure, here we go, Splunk in the cloud. And send data up to them, and then they run all the servers for you. But, Machine Learning Toolkit. Yeah, I'm guessing it's just helping out with machine learning stuff inside of there. There's also a couple apps I know that are in here that are like, oh, Splunk add-on builder, here we go. So this is an add-on that's just kind of a tutorial for how to make add-ons kind of thing. So, because you can, like, all of these add-ons that we see inside of here, you can make your own as well and do all sorts of stuff with them. So that's why they have all the little random helpers. If you're really good at it, you could actually go into like the Juniper add-on and take it apart and tweak it and stuff too. But I'm not that good at that because regular expressions are hard. Lastly, what time is it? Quarter after. Okay. So the other one, just as a random heads up, if you want to look at monitoring data, just health of the box, if you go to settings and then monitoring console, it'll give you all sorts of stuff. This box isn't doing anything right now because there's no data being sent to it, but you can see that it's giving you hardware stuff. You can look at the one that's relevant for me is license usage to make sure you're not violating your license. So that's a thing. Anyway, enough with that though. If you go, just hit the Splunk little home button there. I don't have any like we're not going to radically go and catch the bad guy, because what I did, it was just point the IA Labs core firewall at this for like 40 minutes or so. So we just have some random data in here to play around with. So not necessarily security through obscurity, because you'll be able to look at all the firewall event logs for that 40 minutes of last night. But it is what it is. So if you go to data summary, it's going to, like, when you first even set up all those listeners and stuff like that, Splunk's just going to be sitting there like, I'm listening. When you go to data summary is where it's actually going to tell you, I'm actually receiving input from this particular IP address. When you keep going, I set up the listener, the syslog listener, to just load the entire Juniper module. So it, when it's listening, detected some of the data is firewall log data, like allowed and blocked packets. Some of the data didn't match, but it's like, I know it was Juniper data, it's just not firewall stuff. So this could have been things like, I committed a firewall configuration change. Is that firewall specific? No, because I can commit a change on our fiber channel infrastructure routers or our switches or whatever, right? You can commit configuration changes all over. So that's what's going on there. If we just click this source type, it will actually build out the search for us. So if you notice, it says your search will automatically pause in 23, 22. It's doing a countdown. There's only about 50,000 events in this particular box. But when you run a query and it's like going through its index and loading results and finding more results, it'll just keep doing it forever until it runs out of data. So like the iLab main Splunk that has millions and billions of events, Splunk has a timer if you run, like, this is basically the select all query that I just ran here. Because it's just going to load everything, and it did. If you notice it loaded 51,665 events. In the case of us not violating our license on the DS or the iLab one, it would load it, and then finally after 30 seconds, it's going to be like, there's no reason for me to go load more data, right? This is silly for me to load more because it's going to load millions of events in that period of time. So if we wanted to look at, let's look at the DNS traffic. If we wanted to find DNS traffic in here, what could we search for? You notice inside of the UI, Splunk, now that we've said, like we don't have to say that it's Juniper firewall stuff, but down here it's saying like, of the data you just queried, here are interesting fields that might be relevant to you. So if we're looking for DNS traffic, what could we look for inside of here? Like the year is not going to be so exciting. Yeah, oh, actually we could go, yeah, destination translated port. I was just going to do dest port. Same difference, essentially. What would be the difference between the destination port and the destination translated port? I guess it'd be before and after NAT.
Yeah.
So in the case of DNS traffic, is it going to be changed before and after? No, destination is still going to be 53, so it doesn't really matter. So if we go destination port, it's going to pull up, like, here's a summary of all of them. So let's grab 53. And it's going to load up all of these particular machines in here. So that's nifty, pulling in all these different event logs. It's still, what do we have, 10,900 events? So that's still not helpful. So what we can actually do is pipe these results into, technically from the sense of map reduce. This is mapping data, what we've just done right here. We've gone in and gathered all this data into a pile. Now what we want to do is reduce it into like a disseminatable format. So if we use the pipe character, where's pipe come from? I'll even take the key on the keyboard. Where do you get pipe from?
Above enter.
Above enter.
With backslash.
So pipe is like the universal way of, like in Unix OSs, of taking the output from this command and doing what with it? Shoving it over to the other command. So you usually pipe stuff into grep all the time. Why do we pipe stuff into grep?
Sort.
Dude, we gotta like search and source it, right? Or search and sort it. So if we pipe this into chart, what we can actually do, if we go chart, count by, let's go source, didn't I have it in there? Oh yeah, srcip. It will take this bunch of log data here that we have, which is really hard to disseminate, right? It's really hard to take all that crap that we don't care about if we just want to see who's talking in DNS. So now we can see there's a few hosts in there. And if you actually go a step further over to the visualization tab, and I don't know what type of chart it's going to default to. So if you just go to chart type and just click pi, because pi is better all the time, right? Who doesn't like a good pi? We see these are the hosts that, per at least this filter that we have been talking on port 53. So, any guesses as to what 192.168.100.100 is? That's 61,000 UDP 53 logs. So that is where all of the, like, basically student VMs, like if you have a lab or something inside of the iLab that uses the internet, those all get put behind an additional firewall where you have to like hit the captive portal and stuff like that. So this is the other end of that firewall going out to the internet. So the data sort of kind of technically gets double logged, but that's fine. So this is all student VM traffic. So I this is my personal like way of making IA Lab easier. When I see traffic from a 192.168 sort of subnet, I instantly know if it's doing something weird. I'm just going to ignore it. I'm like, yeah, it's some student's VM being weird. I don't care about that. Whereas if I see something like 172.16.4.13, which I don't offhand know what that is, but it's not, that's fine that it's asking DNS questions. So if I see something like that generating weird traffic, I know that's a part of infrastructure. There's a server doing something weird at that point. So that's the IP scheme kind of thing. So with the exception of this one, any guesses as to... Actually, let's take a step back. Would this be weird for a business to have their DNS traffic look like this? Like there's like 55 different sources of DNS traffic going out to the internet. Is that abnormal?
Well, not if they have a separate firewall for all the workstations, for example.
So there's a separate firewall for other workstations.
Like you got
Yeah. Sure, that'd be different then. Would a normal business, would their clients ask servers out on the internet DNS questions? Or who would they actually ask? Not before then even. You won't even go out to the internet. In a normal instance, if we look at pretty much any business in the world, there's going to be a DNS server inside of the network that everyone's configured to talk to. We don't want all of our clients to individually go out to the internet and ask a third-party DNS server. We want them to come ask us first. So if this was, I don't know, a random bank down the street or something like that, and I pulled up their data and looked at this, I would expect maybe this is their domain controller. Their domain controller should be going out and crawling the internet and looking for DNS data. The rest of these, like, you shouldn't be speaking DNS out on the internet. That's a no-no right there. So we'd start to look to see what's going on there. And I have to like reveal all the secret sauce, but this particular machine here is a domain controller. So this is all student VMs, and probably what's honestly happening is this IP address is really going to this IP address a bunch to talk about stuff. So that's the charting. That's neat. There's also, if you use head and tail, what would that command be used for? Yeah. If we've got a 50 megabyte log file, we don't want to open that up. Or if you're in Linux, you don't want to cat that file because it's going to be scrolling for a bit, right? So if I have a 50 megabyte log file and I'm trying to troubleshoot something that just happened, I want to just see the last 10 lines or something like that. So I'd use tail. Same thing works here. Even with this current query, that's going to pull up, frankly, just a ton of data that's just not relevant to us. So we could come in and pipe it to tail. Actually, I think you can just do the raw number. You just go tail 10, 20. There we go. It'll just pull up the bottom or the most recent 20 events in there for us. So it starts to pull in, like, kind of make data a little bit easier to see. Same thing works with head. Head 10. It'll pull in the top 10 instead of the bottom 10 events out of the log. So all of these are just kind of to make life a little bit easier. The other one is dedupe. Let's go see if we can do deduplicated by source IP. So lots and lots of individual events going on in here and lots of repeated things. So deduplication is going to remove duplicate entries. So if we have traffic coming from multiple sources, when we deduplicate it by the source IP address, we're only going to see all those entries once. So that's just another kind of going for like tools of how to carve apart data inside of here. we could go through like Splunk PowerPoints of, and now you could use this query and that query, but I'm more apt to let you figure those out on your own kind of deal. So the other interesting one is, like, we look at the statistics side of it when we pipe it over to chart kind of thing. Then statistics would chart by, yeah, that works. Statistics will populate out with the actual just raw, got to hit enter, data summary inside of there in just sort of spreadsheety format. That's neat. This is the one part I said I would show you that wasn't necessarily a solid firewall thing, but other types of data could come in handy. And actually there is a pattern kind of thing that we can do. So let's go for larger patterns going on in there. So the indexing engine can actually go and look at this volume of data we have in here and say what kind of things are repeating inside of this data over and over. Now in the case of the firewall logs, it notices that RT flow session create is repeated a lot. Well, in the case of a firewall, that means that there's a TCP session being built up. That's how Juniper logs that data. So is that exciting of a repeating pattern of data? No. But let's say we are a shopping cart website developer and we have people shopping on our website. We can literally come in here, and we could actually even do it with this, just search for error. Not any specific field or form or source or whatever. We literally are just searching for the text error. Is it possible that our website would generate the text error at some point? Yeah. So with the pattern searching, which it's angry about here because it's not going to do anything, but with pattern searching, we could actually find, like, there's a pattern of users when they go to add this item to their cart, they generate an error. So that's where that starts to kind of piece together and become more helpful for us. Ooh, there was actually 2 errors generated. SNMP. I wonder, is that at the same time? I bet that's when I committed configurations because it had to restart the SNMP service. So, anywho, does anybody have questions on Splunk stuff? Nothing? So, there's, like I said, in the end, the exciting bit of this is that we're just sorting through log data. It's just way, way better to sort through it this way because it's way faster to try to find certain events going on. So what we will have pushed out will be a lab. I'm still testing a couple things because I want to make sure it's not like impossible. But testing out a lab that's basically going to be scavenger hunting data with Splunk. So, like, can you find these particular events going on and stuff like that. So that is Splunk Day. So, anything else? I don't think I had anything else we talked about in the other class. With my exciting PowerPoint. Yeah, there weren't any cats on it. No. I suppose I should stop the recording. No cats or goats.